In this lesson, we're going to look at how to find the equation of a straight line. I went over this on Friday in the lesson, but for those of you who weren't there or have forgotten since Friday, because Friday was a long time ago, here's a recap. So here in front of us is a straight line graph. Now, I haven't written any coordinates on the axes. That should prevent it from getting too messy, but let's assume this is 1, 2, 3, 4, 5, etc. And let's assume the same thing up here, that would be 1, 2, 3, 4, 5, etc. Okay, now what do we need for a straight line graph? If you remember rightly, a straight line graph is y equals mx plus c. M stands for the gradient and c stands for the intercept. Now to find the gradient of the line, we usually make ourselves a little triangle. So to make the triangle, you want to find two nice points. I've got two lovely points here, the intercepts with the axes. And I've actually got a natural triangle, so I'm going to use that triangle. Now, m, the gradient, is equal to the rise divided by the run. That means how far up we've moved divided by how far across. Well, how far up have we moved? We've moved 2 spaces. How far across have we moved? We've moved 2 spaces. So my gradient is 2 divided by 2, which is 1. So automatically I know my graph is y equals 1x plus something. Now this little c is where it crosses the y-axis. So I look at my y-axis, remember y to the sky. Where does it cross? It crosses here. What's the value there? It's a 2. So it's y equals 1x plus 2. Now we don't normally write the 1. So I can, if I want to, just delete the 1 and leave it as x plus 2. And that's how to find the equation of a line when you're actually given the graph. Now, in Tuesday's lesson, we're going to look at how to find the equation of a line given 2 points or given the gradient in 1 point. So we're going to look at the trickier aspects, but this is the stuff that you should be comfortable with since year 8. Right, the other thing I've asked you to do this week, or in the lesson, ignore my board. Let's get rid of all that. See, I still use my sleeve even at home. We are going to look at how to sketch a graph. So, for example, if you were given an equation such as this, how do I go about sketching it? Now, there's the calculator way and the non-calculator way. You need to know both. This could turn up in your GCSE in the calculator section or the non-calculator section. So let's have a look at what to do. Generally, the easiest way, and this is a great way for doing more complicated graphs, we draw a table. I have an x value and I have a y value. Now, you will probably be told what your x values are. So let's make them go from -2, -1, 0, 1 to 2. There we go. Now, without a calculator, we're going to feed each of these numbers into the equation to work out what y is. So what does it tell me? It tells me that if I take an x and I double it and add 3, out will come my y. Very important you understand what that actually means. It means take x, double it, and add 3. Now here's a little tip for you. Because this is a straight line graph, it's going to follow a pattern. Negative numbers are trickier than positive numbers. So let's go and do the positive numbers first. Let's start with the easiest one. Let's try 0. What happens when we double 0? We still get 0. And then we add 3, we get 3. What happens if I double 1? I get 2. Add 3 gives me 5. What happens if I double 2? 4 plus 3 is 7. I'll write that in black because I realise that my pink is just a little faint there. So this should be a 3, a 5, and a 7. Can you see what these are going up in? They're going up in 2s. How else did I know they were going up in 2s? There's a 2. Remember how to find the nth term of a sequence? Whatever it's going up in gets the n. So the coefficient, the number in front of the letter, the variable, always tells you what it's increasing by, and it's going up by 2. which means we can now work backwards to know that that was a 1, and that one was therefore -1. Of course, you can work them all out. Then you plot these coordinates, join them up, and if they don't form a straight line, something's gone wrong. Right, let's remind ourselves how to do this on a calculator. Now, your calculators might not be as complicated as mine, but if we go into menu, and your calculator will have a menu, there'll be something that says table. Okay, my table's there. Your table's probably number 3. The table comes up with an f of x. Now, what I'm going to do now is I'm going to type in the equation. So f of x is the same as y. So I'm going to type in 2x plus 3. Now, on your calculators, you'll find x in red above the bracket button. To get any red buttons, we push alpha. So there's my 2x, and then I'm going to add 3 to it. Now, ignore g of x. If you've got the more fancy calculators, you will have a g of x. I'm just going to push equals because I don't want to worry about it. Now, your calculator will say start. Where did we start? We started at -2. Where did we end? We ended at 2. Now, in the less sophisticated calculators, this will be a new screen each time. Step. Step means what are my x's going up in? Well, I've gone from -2 to -1 to 0 to 1 to 2. They're going up in ones. So my step is 1, push equals. Now let me put that up to the screen there. There are my coordinates. I've got an x and a y for every single one. It's the same as my table. Look, -1, 1, 3, 5. And if I scroll down, I can get my 7. So there is another way of how to do this. So quickly recap. You go to menu, you find table, you type in your 2x plus 3 using the alpha button to get your x. You put down what you're starting with, which in this case was -2. You're putting what you end in this case it's 2. What are your x's going up in, which is 1. Hit equals and the coordinates are worked out for you. Remember, in a calculator paper, you are more than welcome to use this. Now, there are other ways of sketching this graph. So you might have learned the gradient intercept method. The gradient intercept method looks like this. It says, I'm going to start with my intercept. My intercept is 3. So the first thing I'm going to plot is 3. There is 3. I know it's going to go through 3. Now my gradient is 2. Remember, gradient is rise over run. So for every 2 steps up, I'm going 1 step across. So there's 3, 4, 5, 2 steps up, 1 step across, if that's my 1. And there is my graph. Okay. 1 should be 7. Sorry, 5, because I've got up 2. Sorry, apologies about 1 is to 5. And 0 is 3. There, done. Because I've gone 2 up and 1 across. Because 2 divided by 1 is 2. Table method is the one that's most commonly used, and it's used for more complicated graphs. So that's the one that you should be very, very comfortable with. This is a one, if the exam says to you, you have to use, you're not allowed to use a table, then that's the way you do it. Thanks. I hope this helped.